has a negative analogical relationship with alpha, gamma, and delta with respect to P1. Well, we see P1's here, we see P1's here, we see P1 here. If it's a negative relationship, then we immediately recognize that P1 can't populate any of the remaining 3 quadrants in beta. Right? P1 is not going to be able to populate any of the remaining 3 quadrants in beta because it's a negative relationship to alpha, gamma, and delta. Right? So we know something about beta now. Beta cannot have property P1. So there's no P1 in beta. Okay, beta has a negative analogical relationship with alpha, gamma, and delta with respect to P1. Okay, beta, gamma, and delta have a positive analogical relationship with respect to P3.3. Beta, gamma, and delta have a positive analogical relationship with respect to P3.3. 1, 2, 3, 1, 2, 3, 1, 2, 3, P3.3. So P3 has to go here. Okay, we're getting close. Almost, we're filling up more and more of the quadrants, right? So beta, gamma, and delta have a positive analogical relationship with respect to P3.3. Okay, simple. Next, beta has a positive analogical relationship with alpha. Beta has a positive analogical relationship with alpha, okay, with respect to P2. With respect to P2. What we recognize, though, is what was given in the example, and this is a trick, I obviously did this for a reason, is that I didn't give you the meta property quadrant location. I just gave you the secondary quality, or the secondary property P2. If we see that beta has a positive analogical relationship with alpha with respect to P2, well, P2 could go here, or P2 could go here. You don't know where it goes. You don't know where P2 goes. You don't know that it goes here, right? Because that would be P2.1. It could go here, right? I could maintain the truth of both claims, right? If P2 is here, then it would be true that beta has a positive analogical relationship with alpha with respect to P2. But if I put it here, it would also be true. So with respect to beta then, with respect to beta, it could be the case that it is we're talking about P2, it could be the case that it's P2.1 or P2.2. We don't quite yet know. So I can't populate this yet, right? It could be 2.1 or 2.2. We don't yet know, but we know that one of these two has to be P2. We're not sure yet which one. Okay, so beta has a positive analogical relationship with alpha with respect to P2 and a negative analogical relationship with gamma and delta with respect to P2. So if we know that it's positive here, we just don't know where P2 goes. Well, if P2 goes here, but it's negative in one of these two, but it's negative with respect to delta and gamma, then it has to be the case that delta and gamma don't have P2. Right? Delta and gamma cannot have P2 if it shares a negative analogical relationship. We don't yet know where P2 goes. This is the really difficult part. I purposefully made it complicated. We don't know yet where it goes, but we know that it has a property. Right? So if it's here or if it's here, at this level of the analysis is irrelevant. We know that it's in one of these two places and it shares that attribute positively here, but it shares it negatively. It does not share that attribute with these two, so we know that gamma and delta also do not have P2. Right? So we know that gamma and delta do not have P4 and do not have P2. Okay, so beta has a positive analogical relationship with alpha with respect to P2 and a negative relationship with gamma and delta with respect to P2. Okay, so they don't have that. The last sentence, and this is all we're given, is alpha and beta, these two, alpha and beta, have a positive analogical relationship with gamma, have a positive analogical relationship with gamma with respect to R. Right? All that's given, alpha and beta have a positive analogical relationship with respect to gamma, with respect to gamma, in the analysis of R, right? Alpha and beta have a positive analogical relationship with gamma with respect to R. That's all we're given. So now we really have to think, because we have 1, 2, 3, 4, 5, 6, 7 quadrants unpopulated. And we've arrived at the end of our analysis. So we really have to think, and this is where it's tricky, because you're not given any more information. It was difficult enough arriving at this, but now we have to finish populating the remaining 7 quadrants. How do we do that? Well, you need to recognize that we didn't just write this here for no reason, right? This was written here to help guide us, right, as preliminary tools to help guide us to populating the remaining 7 quadrants, which is not, obviously, a simple task. This is why it's called critical thinking, right? If we have, as we've seen at the very top, the only options are P1, P2, P3, P4, and R, well, we have P1 here. We know it doesn't have P2. It has P3. We know it cannot have, here, delta. It has P1. It cannot have P2, from what we saw earlier. It has P3. We know it cannot have P4. The only other option is that both quadrants of delta are populated by R. So our delta is complete. We've solved delta. We've solved delta, right? Delta has been solved. Why? Because we have property 1. We know from the earlier analysis it can't have property 2. We have property 3. We know it can't have property 4. And the only property left are 2 random property generators, so both quadrants 1 and 2 of delta have to be random property generators. It's the only way. Okay? So delta's solved. Okay, but we look at gamma, right? Gamma similarly has property 1. We know from earlier it can't have property 2. It has property 3. We know from earlier it can't have 4. The only thing left is to generate 2 random property generators, so we know gamma has to look like that. So gamma has been solved. Or delta has been solved. Gamma, I was right. Gamma has been solved. Okay, all that's really left is alpha and beta, right? We know that beta has to have a random property generator, right? And actually now we see, before, the last sentence, alpha and beta have a positive analogical relationship with gamma with respect to R. So there's only one thing that alpha could possibly have, right? Because it has a positive analogical relationship with gamma with respect to R, there's only one space left. So we recognize alpha has to have R in that location, quadrant 2. So alpha is done. And then finally, beta. The question is, do we still know, right? We know that it shares a relationship, a positive analogical relationship with respect to R for both of these groups, but that seemingly could go anywhere, we think. And we know that it has property, I think it was P2, beta has positive analogical relationship with alpha with respect to P2, but where could it go? Well, if you look back in the rules, and this is why reading your rules are important, we'll see that the rule says the random property generator R cannot occupy the first quadrant of any group. It doesn't occupy this quadrant, it doesn't occupy this quadrant, with the exception of delta. So what do we recognize? The random property generator has to go here. Random property generator has to go there in that location. And that means that P2 has to go there, right? So that's the solution. That's the solution. So this is how your analysis should look, right? Your analysis should look like that. So that is how we apply these concepts to an understanding of critical thinking. And it definitely wasn't a simple task, but you know, hopefully you made sense of this, right? So with that, very long, tiring intellectually draining lecture, but I think it's a good way of recognizing how to structure very complex relations. And as I said before, I've used exactly this to go about solving the cube in a way that it's never done before, because I recognize the distinction in meta properties as applied to the cube, use a heuristic model, came up with a new way. So it's not a question of if this works. This works. The question is, how can you take these concepts and adapt it to whatever interests you? I've already done what I needed to do with this. I've validated my concepts in practice. Now it's getting the information out and having you augment it and design it and transform it into something that will be useful for you in whatever it is that you're interested in. So with that, I appreciate you taking the time to watch this extremely complicated segment in critical thinking. I'm Dr. Jason J. Campbell. Have a good day.